All right, so here we have number 15, a integration by parts problem. And when I look at this, I think it's easier to take the derivative of an exponential function. I don't know, it's basically the same as taking the integral. And so when I'm using integration by parts for number 15, I'm going to set u equal to 3 to the x. dv has to be everything else in the problem, sine of x dx. So du is 3 to the x, and then e to the x stays exactly the same, but 3 to the x gets multiplied by the natural log of 3. Then the antiderivative of sine is negative cosine. So we apply integration by parts once, and we find that we have negative 3 to the x cosine x, that's uv, minus the integral of v du. Oops, I forgot my dx on my du. There we go. And then I see a double negative, so I'm going to go ahead and deal with that, make that into a positive. It didn't really seem to get much better. In fact, things seem to get much worse. And sometimes that happens with integration by parts. Try doing it again, choosing the same functions as your u and your v. So I'm going to set u equal to 3 to the x, and I'm going to set dv equal to everything else, cosine x dx. I'm ignoring this natural log of 3 because it's a constant that I can just throw in front of the integrand anyway. So du, just like before, 3 to the x, natural log of 3 dx. V, antiderivative of cosine, is sine. So we can set up our thing. I'm just going to drop this thing down. Negative 3 to the x, cosine x, plus, I pulled natural log of 3 outside of the integral. So then I have my u, v, minus integral of v du. Okay, that's fun. Now what I hope you notice is that we got back the original integrand down here. We got back the original integrand down there. There's a sine of x and a 3 to the x. So what I typically do is I call the original integrand the letter I. And then we have I equals a bunch of junk. And over here in the bottom right corner of the screen, we have I showing up one more time. So let's just rewrite the problem, and I'm going to distribute the natural log of 3. So let's rewrite it in a different color. What we have is I equals negative 3 to the x cosine x plus natural log of 3 times 3 to the x sine x. And I'm distributing the natural log of 3 minus natural log of 3 squared times I. Because the natural log of 3 that was remaining inside the integral, I pull that in front and I distribute the natural log of 3 that was there. So that's why I got the natural log of 3 squared. And so what I can do is add that term over to the left side. And so I have I plus natural log of 3 squared I equals negative 3 to the x cosine x plus natural log of 3 times 3 to the x sine x. Left side has an I in common, so I can factor out an I. I times 1 plus natural log of 3 squared. On the right side, they have a 3 to the x in common, so I can factor that out. 3 to the x times negative cosine x plus natural log of 3 sine x. And then divide, and you have your answer. I is the integral is the numerator, 3 to the x, negative cosine x, plus natural log of 3 sine x, all divided by 1 plus natural log of 3 squared. So that's called cyclic integration by parts because we did integration by parts once. We did it twice. After we did it the second time, it cycled back to the original integrand, and that we were able to solve for it algebraically. So there you go. That's problem 15. Ask for more questions if you need them.